All right, so this is lesson 3.12 of our Pre-Calc 12 class. Unit 3 is called Exponential and Logarithmic Functions. Lesson 12 is the last lesson for this unit. It is called Solving Exponential Equations. So we've solved logarithm equations, now we're working on exponential equations. To solve logarithm equations, you turn a logarithm into an exponential, which gets the x out of that function. So now if you have an x inside of an exponential function, the way you solve it is turn it into a log function. So let's take it back. We already know how to solve some exponential equations. At the beginning of this unit, we took something like 2 to the power of x equals 8, and well, first of all, we know intuitively that 2 to the power of 3 is 8, right? So we know that our answer is going to make sense here. The way we did at the beginning of this unit, though, is we said, okay, let's find a common base of 2 here. So 8 can be represented as 2 to the power of 3. So we have 2 to the power of x equals 2 to the power of 3. Since they have a common basis, I can set their exponents equal x equals 3. Okay, so that way it works for some problems. But you see, Fancy Poo wants to do a way that works for all problems, all exponential problems with an x as an exponent. So the way Fancy Poo is going to do it is he's going to take the log of 2 to the power of x and set it equal to the log of 8. He's going to take the log of each side of the equation. Exponent properties tell us that if we have log of 2 to the power of x, we can make that x a coefficient of the log function. Okay, so that property right there gets that x out of this exponential function, and just as a constant, or just, it gets it out of that function. So that's what we want. So now we have x times log of 2 equals log of 8, and now we can just divide each side of the equation by log of 2 to isolate our x. Okay, so now there's a couple things we can do here. If I have, remember our third property, or our last property we learned about for logs is the base property. We can take a log, a log of base 2 of 8 and split up as log of 8 over log of 2. Or we could do, in this case, go the opposite direction. Log of 8 over log of 2 is equal to log base 2 of 8. And we happen to know that log base 2 of 8 is 3, so we can just go ahead and solve this for x equals 3. So the next question is why? Why do I want to go fancy poo? Why do I want to go fancy poo on exponential equations? And I believe I've said fancy poo like 5 times so far, and my goal is to say it at least 11 times. So we're going to fancy poo this thing a little bit more. Okay, so now the reason why I want to go fancy poo is because some of these times the answer is not going to be so intuitive. So if 2 to the power of x equals, instead of 8, equals 9 or 10, well, now x is going to be some decimal number. And Fancy Poo is going to let us do this without using a calculator. So here's how it works. I'm going to take the log of each side, Fancy Poo, and so we'll get log of 2 to the power of x equals log of 9. Bring the x out front, divide both sides by log of 2. We get x equals log of 9 over log of 2. We can simplify that as one final log. X is equal to log base 2 of 9. And so that's going to be some decimal answer. I can't do that in my head, but we don't have to because we did Fancy Poo, and that rhymed. Okay, so the next one, same procedure, but instead of 9, we have 10. So we take the log of each side, bring the exponent of x up front, divide both sides by log of 2. X is equal to log base 2 of 10. All right, so here's why we want to know Fancy Poo and not just basic poo. All right, so let's look at some examples here. The first example, we want to get the exponential piece by itself. The exponential piece is 10 to the power of x. So I'm going to divide each side of the equation by 180. So we're going to end up with 10 to the power of x equals 1/3. Okay, and so then take the log of each side. Means I can bring this exponent of x out front as a coefficient. Divide both sides by a log of 10. I could rewrite this log quotient as a single log. And if we recall, 10 is the default base. So if I don't put any base at all, it's going to be base 10. So really I could just write this final answer as x equals log of 1/3. Next example is an example with e. So if I have 51e to the power of x equals 510, I'm going to divide each side of the equation by 51, leaving me with e to the power of x equals 10. Okay, so now because e is my base, instead of taking the log, which you could do, you could take the log, we'll get the same answer eventually, it'll just take more work. But because it's base e, I'm going to take the natural log of each side. So if you recall, natural log of e would mean that we'd be taking log base e of e, which would be the same in exponential form would be e to the some power equals e. And so because of that, we know that the natural log of e is going to be 1. So that helps me out here. So when I take the natural log of e to the power of x, the x becomes the coefficient. Natural log of e becomes 1. So we just have x equals the natural log of 10. That's smooth. I like that. Okay, a couple more examples. 10 to the power of x over 2 equals 80. Take the log of each side. Bring the exponent of x over 2 as a coefficient on the log. Divide both sides by a log of 10. And recall, we can write this as log base 10 of 80. And because 10 is the default base, I could just write this as log of 80. Another way to think about that is that log of 10, since it defaults to base 10, that makes log of 10 equal to 1. So we could also say this is log of 80 over 1, which is just log of 80. Okay, so a couple ways to think about that. So now we have x over 2 equals log of 80. Multiply both sides by 2, and we're going to call this good enough. If this was a quiz, I would say good enough. However, if you know your log properties, you know that we could make that coefficient of 2 as an exponent on that 80. And you could say log of 80. And because you know that 80 is a number you can square, you could write this as log of 6,400. And that would be correct too. It would be a mad calculation / arithmetic flex, and you're more than welcome to flex on your next math quiz. However, if you get to log of 80 and you do the arithmetic incorrectly and get me like x equals log of 640 instead of 6,400 or something like that, if you mess up that flex, I'm going to dock you the points. So it's safe not to flex on a math quiz unless you really feel like, I don't know, whatever you feel like. But just know this is good enough right here. This is far enough where I can punch it into a calculator and we get happy. Okay, so next one, same procedure. Take the log of each side. Bring the exponent down as a coefficient of the log. And then we're going to divide each side by a log of 2. And then we're going to divide each side by 4. Couple more examples, same procedure. I'm going to first divide each side by 28 to get the exponential by itself. I'm going to take the log of each side. Bring the exponent down as a coefficient of the log. Divide each side by a log of 10. Since it is log of 3 divided by log of 10 would be log base 10 of 3. And since this defaults to base 10, I'm just going to write it log of 3. Again, you could just think of this as x over 4 times 1, which is just x over 4, either way. Then multiply both sides by 4. So again, we could simplify this. This would be, if you brought the 4 as an exponent of the 3, it would be log of 3 to the power of 4, which would be log of 81. If you put this answer, or log of 3 to the power of 4, or log of 81, I would mark any of those correct. All right, so next one, again, analogous solution procedure. Divide each side by 70. Take the log of each side. I noticed the 300 divided by 70 doesn't come out to a nice clean number. And I don't want to do with decimals, so we're just going to leave that fraction 30 over 7 in our final answer. Yes, that's allowed. All right, so take the log of each side, bring the exponent down as a coefficient of the log, divide each side by a log of 10, so that's basically dividing by 1, so we just get 2x equals log of 70, or 30 over 7, divide both sides by 2, or I could say 1/2 log of 30 over 7. And if you really wanted to flex on that one, I would make that log of the square root of 30 over 7, but that's if you want to flex. And so we've reached the end of this unit, and we are flexing all over logarithms right now. So um, you have now, if you stick with us the whole unit, you have now become the master of logs. And I'm going to say it. If you've been counting, fancy poo.